Hello there, everybody. This is Orghosina speaking, and today we'll be discussing about cWAN, our SD-WAN device by Credo Networks. So this will be a demo video of what are the features that we have in this device and what kind of utilities this device provide with load balancing and centralized policy, as well as firewall rules and so on and so forth. So without wasting any time, let's dive right into it. To begin with, these are some of the topics that we have. I won't be discussing the topics from here, so we'll just go to the slides that we have. So this is the architecture that you see. On the right, we have our server, where our provider is hosted, and then down below we have our provider, which basically acts as a device. When we onboard any of these devices, they basically go to the provider, and all the other devices are edge devices, which are basically devices that go to different locations, and this whole connection is divided into three planes. One is control plane, data plane, and another one is management plane. So all these are connected to the horizontally scalable provider, and that is what the architecture of our device is. So the provider in case gives us centralized applications, centralized policies, custom application alerts. So this is basically where our web UI also holds, and so whenever we log into our provider, we will be able to see all the devices, and from this provider we can go ahead and access any of the devices through internet. So moving on, this is the topology that we have in hand right now. 65 is the IP address that I have on my end. So basically I'm connected to the Delhi. There are three cWAN devices, one located in Mumbai, one in Delhi, and one in Noida, which is acting as a server. So we have named it as Tenet HQ, and the other two are Tenet Delhi and Tenet Mumbai. So now connecting all these devices to the internet is basically our on our Delhi side we have 2 gigabit interfaces, which is basically 2 dual 4G modules. So we have that in here. It is connected to the internet with 2 SIM cards, 4G SIM cards. And on our Mumbai side, we have 2 broadband connections. So it has these IP addresses for the broadband connection, and under subnet of 66.0. Our Tenet HQ, which is acting as a server, has one internet connection, and this is the internet connection that it has. So as you can go ahead and see here, these are some of the features that we have. The list of features which can be found in networking. The interfaces shows us all about the interfaces and VLAN configuration. Bridge and bond helps us to extend and aggregate our LAN ports, so that we can either extend it by bridging or use multiple LAN ports by bonding. Router shows exactly what routing features the device has. So it will show you all static and dynamic routes that are forming. It will also have a routing table in there. And then there is RAIP, OSPF, BGP, and other routing protocols that are supported by the device will be shown under routers. DHCP is pretty straightforward. It helps us configure DHCP servers for our LAN or WAN interfaces. Then we have DNS, which helps us to create or have a custom DNS. Then we have our tunnels, which is pretty important, as all the VPN SSL tunnels or IPsec tunnels that we'll be creating between branches will be located here. And then we have quality of service, which is basically a way of marking packets through several types of classification, like we can classify traffic through protocols or deep packet inspection or packet matching, or assign DHCP values to these filtered traffic, so that we can tell the device which traffic is more important and should be prioritized over what other traffic. Then we have Net Balancer, which helps us configure load balancing policies, as well as internet breakouts and balancing rules. Then in utility, we have our IP check TWAMP, which helps us show a few metrics like signal quality, jitter, and so on. Then we have our speed tests and DNet lookup, which is also available in utility. In security, we have firewall, which helps us allow or block applications through DPI, deep packet inspection, and then source port, destination port, and so on and so forth. IPS and DPS gives us a brief knowledge about what can be done in the device when there's an attack. So not only we can create rules to prevent an attack, but also detect attacks by our DDoS feature, which basically attacks any DDoS attacks or UDP floods, TCP floods, and SSH brute force attacks. So we'll be discussing about that in the later slides. In filtering, we can allow or block IP addresses, and at the last we have our certificates, which are stored in X509, and this is also what we use for our VPN or SSL tunnels. We create our certificates here and then move to the tunnel to configure the tunnel. This is another description of what we'll be dealing with today. As you can see, all the branches are connected with two tunnels, tunnel 1 and tunnel 2, and they have their IP addresses as such. Now moving on to zero touch provisioning, one of the features that we have in our cWAN device is that it does not require to be configured on site, or it is a smart device. So what happens is I'll just show you the next slide here. So what happens is the management or the service providers will prepare the box by entering the management URL and access key. And once the device is ready to be onboarded, it could be sent to different locations wherever it's necessary to be sent, basically to the customer. And on the customer end, the customer need not to configure the device or have any knowledge about how device work or what protocols are. All the customer needs to do is he can just go ahead and enter these access which will be already entered. So the only thing that the customer needs to do is to give the device power and connect it to the internet through SIM or an Ethernet cable, and then we can access the device and configure the device, as well as push configurations on the device through our provider, which will show up like this as once we have onboarded the device. So something like a flow of how the process happens would be to have a look at this one. First, we onboard the device, and then we configure our internet breakout or gateway. Then we create our certificate so that we can go ahead and try creating a SSL VPN tunnel. Once that is created, we go down to our TWAMP configuration, so that TWAMP will help us keep logs of how much jitter, latency, or signal strength is falling or rising. According to that, we can make decisions to balance load or do load balancing or to do failover. So after that, we have to go to our net balancer, and this is where we configure our breakout or branch breakout. And that's pretty much it. Then we can go ahead and pump traffic. Another feature that we have is our centralized policy. So what happens in the centralized policy is that we have a metadata which can be configured, and through the configuration of metadata we are basically giving the device all the configuration it needs to work, and we are not configuring the device. Basically, we are not pushing the configuration on the device. We are basically making a list of configurations that the device needs, like IP addresses in the Ethernet ports, or the IP addresses in the LAN, and then we can just go ahead and push the policy. We can also create different kinds of action that can be something like automatically creating VPN tunnels, or applying a rule which helps you to block all traffic from Facebook or any other social media websites, or the signatures that we have available. And not only that, we can take a couple of actions, like if we want to disable Facebook and then Google and then YouTube, we can do that, or we can change it up. So if we have action A, B, and C, we can rearrange it, and we can apply the actions in any order, like B, C, and A, or A, B, or A, C, and B. And then we can go ahead and go into jobs. In jobs, we can check what kind of policies, or what if we are using auto policy or group policy. We can go ahead and check in jobs if the policy got deployed, or what happened to the policy. And the next one is our group policy, which is our auto policy, which helps to push configuration on the device as soon as it gets onboarded. So basically, onboarding the device would create the VPN, SSL tunnels, and everything. So we'll get back to that. And I do also have a detailed video of how to do that on YouTube, on this channel, and on this playlist. So feel free to go ahead and check that out. And here it shows how an auto policy setting works, which is we have our templates for our devices with different model numbers. So we use those templates and we provide all the configuration we need to these devices. And once it is done, then we import the action templates, which is the actions that are put in the policies. So policies are basically a set of actions. So we can import these actions and fill them up with our configuration, like our tunnel IP address, or our public static IP address, our port number, all the encryptions that we'll be using, what certificates we'll be using, and so on and so forth. Once all that is done, we can go ahead and call the group policy, which helps us to apply it. So this can be done through auto policy, which helps us to have metadata configured and when we onboard the device, that metadata is used to flash all the configurations. Or we can just create a policy and then flash it to any kind of groups or the devices that we have, which in turn, so the point of this is to create the policy once and to be able to flash it on different devices together. Then we have our load balancing over WAN interface. What load balancing does here is there are two types of load balancing that we support, which is one is over WAN connection, where we what we do is basically take the WAN connection and give it a metric of 1:1. So both the links will be utilized equally, and hence the load will be balanced between both the interfaces. And the other way is the asymmetric WAN interface load balancing, where we increase the bandwidth for one of the interfaces, making that interface work more. As you can see, when we send two packets through this WAN network, we only send one because we have a ratio of 2:1 in here. And this all will be shown. So let's go ahead and go into some configurations now and live demo. All right then. So first we'll go to our browser and have a look at the Edge controller. If we go to our Edge controller and click on list, you'll see that there's a list of devices that has been onboarded, and the green ones are the ones which are up and running and are working right now. So for today, as per the topology, we'll be only using Mumbai Tenet, Tenet Delhi, and Tenet HQ, HQ acting as server and Mumbai and Delhi acting as clients. So currently I'm at the Mumbai site. So what I can go ahead and do is I can minimize this and I'll just check if I'm connected to the, yes, I'm connected with the LAN interface. So now what I'll do is I'll use my file server here and I'll run a admin FTP server on my Tenet server, Tenet HQ, and then try to pull or push data to it. So I have switched on a FTP server there. I'll just go ahead and connect it now. So now we'll go ahead and enter the IP address. And before we enter the IP address, we'd like to check if we can ping that IP address or not. So the IP address on our HQ site is 64. So we'll try the device first. Looks like it's up and running. So we'll go ahead and try the device LAN IP address. The server IP address basically. So we'll enter the same address here, 192.168.64.13 and enter. And as you can see, the server is up and running. So it looks like there's an issue on the server side. So I'll just solve it and come back in a second here. Alright, then I have configured a user there, so I'll be able to connect now. Yeah, as you can see, we are connected to the server now. So we'll just go ahead and start our transfer. We have created this folder called D here. So I have a movie here and I'll go ahead and send it to the server. And as you can see, the transfer has started. So now we can go ahead and have a look on how the transfer is happening. So first we'll have to SSH into our device that we are connected via LAN to. So we can go for this, So we'll just go ahead and SSH into the 65 device. Looks like we logged in. So yeah, now we'll enter here IP traffic, and it will show us -G, and it will show us all the interfaces that it's using. And as you can see here, currently both are balancing. So we're in Delhi. I'll just go ahead and show you the balancing rules that I have already configured here. So if we go to our net balancer where the configuration rules can be found, as in the load balancing rules can be found, we'll see that all the connections here. So we are doing a transfer to the HQ or from the HQ. So as you can see, all the weights are 1:1, and hence here, as you can see, both the data transfers are equal with almost equal speeds. So now if we go ahead and try to do an asymmetric WAN interface, so all we have to do is go here, check out which one leads to HQ, and here in VPN 0 we'll change the weight to 2 and update it. We also have to update the weight on the other side so that incoming and outgoing data is sent accordingly. So we'll open up our HQ tenant. So we'll just pause this for a bit so that we can use our internet faster as I'm connected to this device and the transfer was choking up all the speed. So if we go to HQ here and go down to net balancer, we'll see something similar of what we saw in our Mumbai as in Delhi tenant. And this one leads to Delhi. So this is the one, and here VPN 0 will change it to 2 as well. And now once we have done that, it'll appear 2 anytime now. And now we'll go ahead and start the transfer again. And the transfer has started. So now if we go ahead and check out what is going on in here, we'll see that VPN 0 will be sending twice the data that VPN 01 is sending. So as you can see here, it's giving a speed of 683 to 700, while this is giving a speed of 300 to 350, which is basically half of what VPN 0 is giving, and VPN 1 is getting half of VPN 0, and VPN 0 is getting 2x of whatever VPN 01 is giving. So this is a classic example of our asymmetric WAN interface. And while we are at it, while the data transfer is going on, what I will do is I will go ahead to the configuration and shut one of the tunnels down. So as you can see now, the transfer is on and I haven't messed with the transfer at all. So what I will do here, I will go ahead and shut our connection, which is taking a lot of load. So we'll go ahead and shut VPN 0 on our tenant HQ side. And we'll do the same in here. We'll go to tunnels. This is our tenant Delhi site, which is acting as our client. So now we'll go ahead and shut down VPN 0. So now as you will see that although one of the connections have gone down and VPN 0 is no more transferring any traffic, VPN 1 is, and the transfer as you can see has not stopped yet. It's still transferring data. So even if there is a failure on one of the ISPs, or one of the tunnels goes down, or one of the internet providers go down or have some issue, we can still maintain our session and we won't be losing our session. So that is how load balancing and our failover works. So this is basically load balancing and failover. This is what I did. I switched off one of the interfaces and hence the gap here, and all the traffic which were transferring from the second interface will go to the first interface and switch to the blue one. So now we'll go ahead and shut off this transfer now that we are done with this example. And now we'll get into autoflow. So now the question is, what is autoflow control? So autoflow control is, so we'll go ahead and switch on these VPN tunnels back again, as we'll need these. And while it switches on, we'll go ahead and go to our net balancer. And in net balancer, we'll have our VPN rule. So we'll go ahead and, as in we'll have our balancing rule, and in balancing rule we can go ahead and configure autoflow. So to configure autoflow, first we'll have to classify the traffic. So let's say we are trying to access Facebook here. So we'll go ahead and select Facebook. So this is where we're using deep packet inspection to classify our traffic. And now we'll go to general and send it to the internet, to internet breakout, and we'll select auto flow here. Now what auto flow lets us do is it checks all these performance with our cWAN configuration, and what it does is it'll check if this connection is producing this much of signal quality. So if we go ahead and go to its interface, we'll be able to see the signal strength it's getting right now. So what I'll be doing right now is I'm connected to the Delhi tenet, and this file transfer is also going, we'll be starting the file transfer. And what we'll be doing is we'll go ahead and configure a balancing rule, which is what we are doing here. And we will basically take one of the antennas off the device, which will lead to an increase in signal quality, as in a decrease in signal quality. So it is getting a RSSI signal strength of -65. So we'll put in -75 here, and we'll put the weight to high and hit create. So now what will happen is if we go ahead and open Facebook, and to create some Facebook data, we'll go ahead and start our auto refresh app, which will refresh this Facebook page in every 3 seconds, which in turn will create a lot of traffic from our Facebook, from the browser browsing Facebook. Basically this basically mimics browsing Facebook. So now if we go ahead and see the rule, what the rule states that if any of the RSSIs go beyond -75, then it will switch over to the other interface. So it will fail over. So what we'll do, we'll go ahead and change the network, and before we do, we'll go ahead and plug off one of the antennas. And before we do that, we'll go ahead and go to our dashboard and have a look on where the data is leaving from. So if we go to top N here, you'll be able to select applications here, and from here I'll just check in both the Facebook TLS and QUIC. And as you can see, they are transferring the data now, and this is the data which is getting created. So we'll increase the refresh time a little bit more to 15 seconds, and we'll put this to 10 minutes. We'll have the data from last 15 minutes, and we'll press apply and start. So now as you will see that we'll select our WAN interface now, WAN interface 1 and our WAN interface 2. Just go ahead and check the interfaces once. It's WAN 0 and WAN 02. So as you can see, I have chosen WAN 01 and 02. So they both are transferring data. If we try to see which one is, we can see that both are, especially WAN 2 is basically transferring the traffic. And if we do VPN, I mean if we do WAN 1 here, Yeah, as you can see, WAN 1 is not really transferring any traffic right now. And as per our rule, what is supposed to happen is if any of the connections 75 goes below, then it will switch over. So as you can see, all the data right now is leaving through WAN 1, WAN 01. So if we go ahead and go to interfaces here, we'll see. So we'll just give it a little time to load here. And as you can see, both are at 64 now. And as all the data is transferring through WAN 01, what I'll go ahead and do is to increase this, I'll plug off one of the antennas from the device, which will make the signal drop. And as you will see soon enough that the signal will increase and all the data which was leaving through WAN 0 will soon shift to WAN 01, and this will start clearing off. So we'll just go ahead and refresh the page, and as you can see, it has already reached -90. So we'll just give it a minute to load now. As you can see that the connection is going down here and all the traffic is now been sent from WAN 02. So we'll add WAN 02 here and remove WAN 01. As you can see, Facebook is still accessible, which means that although that one of the connections have gone down here, it has failed over to the other interface. So as you can see now, WAN 01 is losing more of the connection now, and if we go ahead and go to WAN 02, we'll see that this TLS connection, which is basically our Facebook data, is all leaving through our WAN 2 now. As you can see, it's still accessible. The Facebook page is still accessible and we are able to connect to Facebook. So now we'll go ahead and talk about our link failover. So I have put the antennas back on, and as you can see, I've started the transfer once again. So we'll just go ahead and switch this transfer off. And now what we'll do is I'll be demonstrating how we can use one application and make it leave through just one of the interfaces that we desire. So as you can see, we have Facebook data here, and if we put another Amazon News, Amazon Alexa, video, and if we go ahead and go to general, and instead of auto flow, we'll be choosing one of the interfaces. So we are configuring internet breakout here. As you can see here, what internet breakout does is it doesn't send all the data to the other branch. What it does, it breaks out to the internet, So any data which is trying to reach Facebook will directly be able to reach Facebook through one of the interfaces that we choose. So here, as you can see, we have two of our interfaces, and we'll choose the WAN01 and update it. We'll do the same again. We'll start off Facebook and Amazon, and we'll put it in a refresh cycle to generate data. So basically every 3 seconds these will get refreshed. So as you can see, these both are getting refreshed every 3 seconds, hence they are creating data. So we'll go ahead and go to our dashboard and see what is going on. So now we'll go to top N and see where the application is receiving internet from. So if we go ahead and filter our traffic, so we'll select here Amazon and we'll select all of them. And we'll select Facebook as well. And as you will see now, all the data which was initially leaving from WAN1, I'll just go ahead and show you the rule once again. And we have set it to leave from our LTE1, which is our WAN1. So if we go ahead and see here, selecting WAN1 here, you'll see that all the data is leaving through WAN1. And if we go ahead and select WAN2, we'll see that almost no data is leaving from this interface, as we have configured the rule here. Configure the rule here that all the data from Amazon and Facebook will be leaving through our WAN interface 1. So that basically shows how we can configure our internet breakout to have specific traffic either take specific tunnels or take specific pathway to the internet from one of the SIMs. This is also can be done with different type of signatures, and also here we have packet matching where we can go ahead and configure any of the interfaces. Then we have source and destination address. We can put our whole subnet here as well. In protocol matching, we can go ahead and select TCP. That will help us to do source and destination port as well as action. And if we want to select any of these, we can go ahead and switch them on. We can also select from new, established, related, invalid or untracked connections. So if we want to block, we don't want any new connections forming, we can click that. And we have time matching here, that if we create a rule and want it to work on some exact times, like if we want something to work on Monday at 5:44, we can just go ahead and configure it here. And on Monday 5:44 from to let's say 6:44, this 1 hour, whatever this traffic is, will be leaving from this interface. So this is how we can get in deep and configure how the traffic filtering will be done. Also make sure to have this logging on and do produce some data here, so that whenever there's any log files generated, we can see them in our logs. So I'll just go ahead and close these and get back to our slide. So we saw this one where we used autoflow to control. So let's say this can be used in very different ways. Like if we have our Zoom meeting or Zoom call which goes on from time to time, or if it's very important, we can actually have a dedicated interface where all the Zoom traffic will leave from. And also we can put in our signal quality control by putting in autoflow, which will help modulate the traffic flow in case there is a connection disruption, or in case one of the sim runs out of recharge data, or anything. If anything goes wrong with one of the interfaces, this autoflow setting or signal quality configuration setting can help us out in there. Not only that, we also have a couple of settings here. If I go back to autoflow, like if we select performance here, as you can see, we have latency, packet loss, jitter. So these all can be calculated and can be used as metrics. An auto calculation of this is can be found in utilities and TWAM. So if we go ahead and we'll just give it a little. Yeah, now if we just go ahead and run it, we'll see that it'll give us metrics. So it's running in the background now. As soon as it is done, it will basically show up in here, and it'll give us the matrix, something like this: that maximum latency of this connection, maximum average latency, jitter, packet loss, and so on and so forth. It'll basically keep a track of these and actually use these to control the traffic flow. So that is all about SAS control. Now we'll talk about firmware update. So once an update is available, we can just go to our edge controller, which basically has all the edges. And in edge controller, we'll go ahead and click on firmware update. In firmware update, you will see all the devices that we have, and once an update is available, we can just select these devices and just update them all, or update them one by one accordingly. So that's all about update. Now if we go ahead and go back to our slide here, the next is also updating, and then we have bridge and bond. Bridge helps us to extend our LAN connection and basically extend our subnet to different geographical locations. And bond helps us in aggregation and failover. We can use two of the WAN interfaces as in LAN interfaces. So two of the LAN interfaces, and if one fails, we can switch over to one, or we can constantly use two and use it as a load balancer. Then we have our IPS rules and alerts, which helps us to filter any kind of attacks and also alert us. So as you can see, there are some signatures available for spywares, worms, and all kinds of pushing and adware. So we can go ahead and select these signatures, and this will help us to detect. Just like here you see that in case somebody is trying to use Tor, not only that Tor won't be accessible, it also will show up in an alert section under our security. IPS will show up in here, and it will give you an exact location of where who on your network, or which IP address on your network is trying to access Tor. So this comes in very handy when you're trying to have a closed network where nobody can encrypt their traffic, and so on and so forth. So IPS also has a hub and spoke scenario where we can put a signature licensing in our hub, and then route all our data from all our spokes to the hub, and have that data filter in our hub. Or we can just go ahead and purchase licensing for all of the devices, and locally have a signature matching done. So that will depend mostly according to the customer and what they are trying to do or what they are trying to purchase here. So the next is our firewall rule. So as you saw before that we configured or classified traffic. So if we go ahead here and go to our edge controller list and we'll go ahead and go to Delhi. So first what we'll do, we'll go ahead and start our Facebook and we'll put it on refresh. So as it'll refresh in 3 seconds. Now what we'll do is we'll go to our Delhi site and give it a little time to load. We'll press on firewall and press on add rule. Before we add rule, this traffic is leaving the interface, so it'll be forward. So we'll go ahead and configure a new rule in forward. We'll click here, apply to all routed and bridge packets, and the action will be dropped. And then in DPI we can go ahead and do Facebook and switch it to this part and hit create. Looks like it's loading up, so we'll give it a little time to load. Yeah, looks like it's done, so we'll hit create. And as you see, as soon as I hit create, it stopped refreshing, and we'll see that Facebook won't be accessible anymore as per this rule. So as you can see here, it's still not working. So what I'll do is I'll go ahead and switch the firewall rule off here. Yeah, as you can see, the Facebook rule is off now. So if we go ahead and see now, we'll be able to see that we are able to access Facebook now. And even when we refresh it, it doesn't go off. So this basically shows how our Facebook policy can block, as in policy through DPI can block different type of applications. And then we have our top applications here, which we already had a look on. So if we go ahead and go to our dashboard or statistics, we'll see a variety of options that is available that gives us data, that shows us what is going on in our network, who's accessing and what port they are leaving. Like just now we saw that we can see which port, which interface the data is leaving from by our top end. And there's multiple other options which basically helps us to see which interfaces or which bandwidth or how much bandwidth is getting used. While this will give us a good interesting view of where and what traffic is going from where to where. Like if we go ahead and see explorers, exporters will see how the egress and ingress interface is working. ACE traffic will show us all kinds of ACE interfaces it's passing through. As you can see, this is all our traffic and where it has already went. And if we go to statistics will give you an overview of the device, like how much CPU utilization is going on and how much memory utilization is going on. In a bunch of time and graphs, it'll denote how much CPU usage was there over a period of time, and we can go ahead and actually change it here and see how much CPU utilization was there in a certain amount of time. So not only that, Edge controller also gives us an option to export, to generate a report. So if we want to generate a report for Delhi, we can just go ahead and click on generate. So here if we go ahead and click on this icon, this will give us this, and we can go ahead and generate. And if we give it like this usually takes a minute or two to load, as it is a lot of information that is getting loaded here, but you can go ahead and download it as reports as well. And we'll get back to this soon. This will basically come up in a second or two now. We'll just give it a minute. So as you can see, it has come up now. It shows transfer rates, receive rates, and everything that has happened to the device in the last 30 minutes. So it will give you a brief descriptions of all the errors that happen in the interfaces, and also it will give you a, a PDF format of it, which you can just go ahead and save it. So that's all about reporting. Getting back to our slide again. So top applications, and as you saw, we did some reporting there, and we saw what all data can come up from reporting. Then we have our global application, which is used when we run out of signatures, or there's an application that is not there in the signatures. Then we can just go ahead and define IPs and protocol and so on and so forth, and actually target that one data transfer, or whatever that is. We can track that down and have a full view of it in here. So for that, we'll have to classify the traffic accordingly. And then in our topology, what we can do is what we have done here is we have given coordinates to all of our devices, so they can be available on the map here in real time. So as you can see, there's a bunch of devices here, there's a couple of devices here, and if we just go ahead and click here, we can see that there's a tunnel, there's VPN 0, VPN 1, which are connected. So this not only gives you a brief detail of where the location is, it can actually give you a lot more details about what is going on in that site. So as you can see, these sites are connected through these tunnels, and it is showing over the map now. And as you can see, the HQ, now we are getting data from HQ, and it is giving us more information about where it has come from, how much the CPU utilization is, memory utilization is, and what are the WAN is receiving, what kind of data. So this basically helps as an overview, as well as branch to branch view of what is going on, and if there was any error, or so on and so forth. So that's all about our topology, and this is exactly what we see as our topology grows. It might get a little clustered as this, but we have some options to filter that too. So that's pretty much concludes the demo that we intended to provide with this presentation and some of the devices we have at our end. Well then, thanks for watching.